Good morning, Dallas. Good morning, US, and good evening, India, and good evening, Bangalore, the Silicon Valley of India. Welcome to the Friday talk show of Global Electronics with your host Rajiv Kulkarni. Every week, we bring you this global electronics manufacturing activity, and we talk with the various professionals, various industry experts to address certain challenges and certain activities that's happening in electronics manufacturing. And those are very informative sessions we bring to you, and so we definitely request you all to subscribe the channel as well as share the channel with your friends and colleagues in the electronics industries. Today's topic is very important and very known topic. It's about the printed circuit board manufacturing, which is we call it as PCBs in short. And PCBs are without the PCB there is no electronics, right? Because that's the heart of electronics. Anything that you want an electronics to work, there has to be a board and there has to be a heart to it, and that is what PCB we call and printed circuit board we call. So, having said that, what are the challenges that we face in the manufacturing of PCBs? People, a lot of people consider it as a commodity, but I consider it as one of the tough and the very challenging product in the electronics manufacturing, because people think it's a very easy to manufacture PCBs. No, and every single day, every single moment, you have the challenge. You have certain issues which comes up in the manufacturing of printed circuit boards, whether it can be design related, whether it can be process related, whether it can be logistic, or whether it can be the surface finish, the warping, or you name it. There are multiple challenges that a PCB manufacturer faces. So today we are addressing those issues, and for solving, I wouldn't say solving, for addressing and discussing that issue, those issues, we have an industry expert with us today. His name is Mr. Venkatesh Rao, and he lives in Bengaluru, that is Bangalore, Silicon Valley of India. And so he works for a corporation, a PCB manufacturing corporation out of India, and he is basically a mechanical engineer with multiple years of experience in various fields in the electronics. Plus, since 20 years plus, I would say he has been in the PCB industry. So definitely I call him as an expert, and he is currently the quality in charge of a company. And who else can be a better person to address these kind of, or discuss these kind of issues? Welcome to the show, Global Electronics. Venkatesh, good evening to you. Here it is morning, and how are you doing this evening, sir?
Good evening, sir. Thanks, first of all, for the opportunity given to me.
Always a
Thanks again.
pleasure. Yeah,
Yeah,
thank you.
I am Mr. Venkatesh. I am basically from Karnataka, born and brought up in Udupi district. And I have 34 years experience in industrial field, out of which last 20 years in printed circuit board. I worked for one of global multinational company called AT&S India Private Limited, almost for 15 years. And last 6 years, I'm working for a Ascent Circuit Private Limited here in near Bangalore. It's outskirts of Bangalore. It's located in Sur.
Okay,
Thanks
great.
again. Yeah.
That's a great introduction, Venkatesh sir. And PCB, what I mentioned is not an easy process to manufacture, and definitely you be in the process, you be in the quality aspect of it. You know, you must be encountering so many challenges on a day-to-day basis. It doesn't reflect the quality of a company, but it is, the nature of business, the nature of product is such that there can be any challenges can occur at any given point of time. So there are certain major issues in the quality issues that I see, that like warping is one of the very common quality issue. People always come, because I have a PCB background too, and that is one of the challenges which was already always being addressed. So what exactly is warping and how does it happen, and how to address the solution for that.
Yeah, see, this is one of the major concern, challenging factor, this defect in warpage. There are so many reasons. It starts with the CCL or copper clad laminate manufacturer and ends with the PCB manufacturer. And the major cause is one is the grain direction. That's nothing but the GD we call. While making a multi-layer board, you need to have an inner core as well as the pre-pack insulation material. And many of process, what people, the PCB manufacturer do, he will cut in-house and then he will use in the inner layer printing process, etching, then AY. Then finally it comes to pressing. Then you need to add the insulation material, wherein you need to match the grain direction, the glass cloth weaving direction. No? Both of pre-pack as well as the CCL should match. Then only you will get the basic foundation will be good. So this is one of the factor. If you go further, the design factor also matters. If you have a improper design, means improper copper distribution among the layers, then also you will get this sort of a warpage issue after the removal of unwanted copper. That means in the outer layers especially. Then what will happen in the design? People say it's my design, you cannot change, but still the manufacturing engineering will have some option to have some thermal pads introduction, where customer also will not get affected. So those discussions should happen before the launch of the product. Whenever the gerber comes, the engineering team will work on that. They should study all those things, and if applicable they should have a EQ, that engineering query they should raise to the designer of the customer. Then they will have a mutual understanding, then they can solve this. These are the two major. In my, I have some slides to show on that. There I can
Please.
explain you also after introducing about my company's profile.
Sure, absolutely. You're more than welcome to share the presentation of the slide anytime that you wish to. And so, warping is that is correct. And what about the electrostatic discharge?
Generally, for PCB, electrostatic discharge is not much applicable.
Okay,
Mainly, it is for the components assemblers, that is,
okay,
people
okay.
who assemble. There, it is of more importance. However, we do face some issues, challenges in the, mainly when we handle the inner cores or the outer cores, wherein copper and it passes through a machine, no conveyor. That time there will not be any earthing. Sometimes that will cause sudden shock to the operator if he is handling. So for which what generally we take during the construction of the layer station or the where we handle the dielectric metal as well as the copper,
Yeah,
the flooring will be electrostatic EST floors, means there will be a earthing factor also considered. And the
correct.
operator who does this layup before the pressing, there he will have a in his clean room shoes there will be a copper strip. It's again earth. The shoe bottom will be having that. So that way we can eliminate. But as such, it's not a challenge for generally
Bare
for the
boards.
bareboard
Bare.
PCBs.
Okay, okay, okay. And I see that there is an like insufficient copper to edge clearance
Yeah,
is an
yeah.
issue.
This is another area where you face the maximum challenges, because see people will define the pitch, line width and spacing, 4 mil by 4 mil, 3 mil by 3 mil, and now HDI PCBs have come already in the market. So
That is true.
generally in India HDI is not that much popular right now, but we are getting, the Indian government is pushing hard for all the designs and other things should be here. In that context, I can say the edge clearance also plays a vital role. So when you have multi layers with 6 layer, 8 layer, then people will not be knowing during the drilling or in the outer layer exposing, but finally it reaches. In AY also we do 100%, but there also you are seeing only 2D. That means X and Y direction only surface inspection will be happening in the optical. So it will compare with Gerber to Gerber and it says okay. But when it comes to the functional test at the end of the process, around BBT we call bareboard testing,
Yeah.
there it goes with the each net. It may from one layer 1 to layer 2 or layer 1 to layer 10 and layer 4, anywhere it can go. That is called X, Y, and Z direction it will move. That time we face these issues of clearance if not proper, annealing is not proper, only
Okay.
very minimum, and your registration system is not good. Means the layer to layer shift, no, or port to
Yeah.
port shift is more than the specified. Then all these issues will prop. Then finally, customer will not be happy when we rejected bareboard testing, because again you need to have a time. No? PCB is
Hmm.
not like a component assembly process. You
Yeah.
start one side, other side you can get the PCB out with the PCBA. Nowadays with the AI having online, so then no much time. The people will ask 3 days you give or 2 days you can give, but PCB is not like that. It's having 30 plus odd main process, then around 20 odd sub process. So it takes almost 15 to 20 days in the normal run, and if additional process will be there, it will be an additional. I'm not talking about the contact time. I'm talking about
Yeah.
the general mass production timing.
Correct. Correct.
4 weeks generally for double set, 5 weeks it will be for four layer and above. This is
So
what about
now,
that. I will give more light on that after the end of the session.
yeah,
I
yeah,
have some
definitely.
presentation for this.
Sure, sure. Now the next question I have for you is overheating. You know, how important
Yes,
it is on for a thermal management
yes.
side of it. You know.
See, this is another challenge. Here, the effect is the PCBs will having more inner layer copper cladding. Like so there are 18 micron, 35 microns, then 70 microns inner layer coppers. As you go higher, as the application demands, you have this heat dissipation factor we have to consider in the design stage itself. Again, here use of thermal pads will help.
Correct.
It will ease out the heat immediately discharges. Another way of avoiding this is use of vias in the ground.
Wires. Yeah. Yeah.
Yes, that will also will dissipate fast, and that maybe it is some designers think that it is costly affair, because you need to have a point 0.3 drills or point 0.2 drills, and as you come down the drill size, the pricing will go up upper side.
Yeah.
So that factor also they should consider. But however, application wise, they decide for more accurate and more precise. People will go with the resin filling vias. That means vias will be drilled, then plate through hole will be done, plating will be done with dielectric material like epoxy resin will be filled on those areas, so that you will have a more stable PCBs even at high temperature applications and thermal shocks.
So when
Mm.
you said VS, basically, there is a when we talk about VS, there is always another question comes or the issue comes is the discontinuing of VS. Sometimes do happen. So that is also a big
Yeah,
challenge. So how that can be controlled?
this discontinuing of wires, there are many factors. The one of the main factor is core to core shift if it happens. Then there will be a disconnection of the one of the layers. It may not connect. The pad will not be there. Zero pad or tangential breakout will be there in the inside the layers. There is a one of the factor. Another factor is during the plating process, PTH or the next process is the plating, final plating. In these two areas, there may be a voids. That's called circular voids
Okay.
or the small pin connectivity. It may pass your BBT sometimes, but during the heat application, it will give away. So this is another risk of wires. And third one is during after the plating, there are few more processes involved, conveyorized and micro etching preparations. There we used to take 1 to 2 microns of copper for proper preparation of the surface. During that time, the PTH hole, if something happens in the conveyorized process, if operator or the machine not detects some stuck and then it passed, the dwell time will be more than the specified. sometimes there will be a chance of taking out the copper inside the holes. All those things will happen. So these things we should be very careful. But it will be known sometimes in BBT, but few times it may pass BBT because of thin continuities. That will be
Okay.
known with the high voltage applications. These are the challenges. But however, at each stage, if you take the stage inspection and the communication to the particular area where the risk is involved, if you control the process, absolutely no problem. We can ensure the right products at the right time without
Okay.
rework. Rework is the risk in the wires. This is discontinued wires is the rework, another factor.
Okay.
Yes,
Okay.
yeah. We should avoid the rework.
Very interesting. Let's take a quick short break and we'll come back. Good morning and welcome back to Global Electronics Friday Talk Show with your host Rajiv Kulkarni. We bring this show every Friday at 8:30 a.m. Central Standard Time of US, and we bring every week a different topic about the electronics manufacturing, the challenges, the trend, or the manufacturability and the process. You name it. I mean, we have different topics every week. Every week, it's a different topic, and then this is basically a knowledge sharing platform, and we would welcome anybody would like to participate. You can write to us at globalelectronics1234 at gmail.com, so that we can then study and we can bring you on the channel to discuss about the product and the electronics manufacturing. Today we have a topic based on the quality challenges that is being faced in the bare boards manufacturing. Bare boards is a very integral part of and a very important integral part of electronics manufacturing. So we have Mr. Venkatesh Rao from Ascent Circuits, who works in Bengaluru, that is Silicon Valley of India, which is based in Karnataka state, and he's basically an engineer with 30 plus years in the industry, and that too he has 20 plus years in the PCB industry. Welcome back to the show after this small break, Venkatesh. So
Thank
you
you.
wanted to share the presentation. Please go ahead now. It's,
Yeah, I will
you can
share.
share. Yeah.
It's visible?
Uh, can't see. No,
No.
sharing is not
Sharing
done.
screen, entire screen. Yeah, entire screen. I have done. Okay.
Oh, now I can see. Yeah,
Okay. Okay.
you can put it in the slideshow maybe.
Yeah.
Yeah, yeah.
Can you see now?
Yes,
I have written here problem comes back, points to ponder for PCB.
sure.
Okay. Always we discuss in our many of the meetings. Definitely problems comes back means PCB. It's simply on a short text I told. It's a joke.
Yeah, yeah, yeah. No,
It's
absolutely.
about my company where I work and connect the future with our performance, precision, and capabilities. Is it visible?
Yes, yes, very clear.
Yeah. And this is our factory background, 25 plus years experience since 1999. And the facilities around 350,000 square feet. And the last year turnover around 310 crores. Around
Excellent.
600 employees and 100 plus satisfied customers with 98% repeat business. That means after sales service is important. So our prime motive is quality and the sales service, after sales service. We are not one time buyer. We don't want to be.
Sure.
And this is the connect, credible, optimistic, nurture, and navigate excellence, committed to it. Okay. This is about the employees, how they distributed, mainly in production 383, semi-automatic our factory, and how we milestones from 1999 onwards, from single site to double site to Indian Space Research Organization. We have delivered boards since 2011 onwards. We got approval, and in last Chandrayana 3, we got a appreciation letter because our PCB is there in the Chandrayana 3. That's one of the credibility credential what we showcase to our customers.
Excellent.
Those are the same lines we use for all other customers also. We don't have separate lines for industry separate, automotive separate. No. It's the same line wherein ISRO boards will go, the same lines automotive lines also will go, industrial products also will go. Okay, so a short description. These we do single side, double side boards, multi-layer PCBs, RF radio frequency boards. Mainly we export indirectly to US also through a Comscope company. Then aluminum PCBs, flexible PCBs. This is solution by industry. Our 83%, 82% is automotive, balance distributed in telecom, consumer electronics, lighting, industrial power electronics, space and defense, and others. These are automotive major customers. Whomsoever you name in automotive, we are there.
You're there.
Maybe some places smaller, few places we are in bigger way. Like Maruti, all they are the for us main customers.
Very
Hyundai,
nice. Very nice. Very nice.
and in two wheeler also we have in TVS, Royal Enfield. Non-automotive like AT&T, Cisco, Honeywell, Altel, Samsung, Bharat Electronics.
Yeah.
Still, all those people are there. We were asking about the some of the items
Yes.
which you want to
Yes.
see. I can explain here. The
Yep.
warpage related, how can occur. The other factors like thermal stresses. There also you during manufacturing you will have a thermal expansion and contraction can cause the board to bend or twist. And imbalanced copper, what I was explaining, layers are not evenly distributed. The board can warp. And improper handling, many times in the oven it will go. The size of the panel will be bigger than the sometimes the oven door, and people
Correct.
will try to push it the oven door. Then after the 1.5 hours, if you take open, that board may get bent. There will be it's all the chance causes. People may not recognize. These are the practical case studies what we found. Then material selection, like glass transient temperature. If you low TG, if you select for a where you have a high temperature application, then it's soft enough, it will bend also. Then GD, I have told grain direction, one of the
Brain
major
direction.
factor affecting the warpage in case of multi-layer PCBs. And prevention, yes, balancing of copper distribution, equalizing component layout, using materials with the high TG, maintaining consistent pressing parameters. That also plays a vital role because the temperature, vacuum, and pressure, they are the important factor, and the cooling factor also important here. All those influences the warpage if not properly maintained, followed as per the technical data sheet of each supplier. Then ensure GD. Okay. Then copper edge clearance, we were asking.
Yeah.
Uh, Insufficient copper to edge clearance as printed circuit board can cause number of issues like shorts. I told corrosion. The exposed copper is vulnerable to corrosion and contamination from the environment. Electrical shocks. There are is a risk for an electric shock to anyone near the board. Damage during routing.
Voting. Yeah.
Places that are too close to the edge of the board can damage during routing. The recommended copper to edge clearance depends on complexity of the board and the capabilities to manufacture. So a design for manufacturability DFM check can help identify any potential issues.
Excellent.
Then electrostatic discharge we are talking about. As such,
Yeah.
it's not much a problem for PCB. Still, I go through for a short brief note. Occur when two objects with different charges come close enough to there, then the electric between them, the scan happen where there is a friction between the PCBs like rubbing, cleaning, and packaging. Here are some preventive use a grounding wrist grip. What I told during the layup also we can have building construction. Then connect your wrist to a ground object like the metal frame of a computer case. Use anti-static bands. Use anti-static surfaces that I was explaining, no, in the ESD clean room. Then wear anti-static clothing. We do use for the clean rooms where we handle inner layers for layer. Then use a static eliminator. Have a NS space between workstations.
Very nice.
Then overheating. That is the
Overeating.
thermal management. What we call use thermal wires. What I told. The splatted holes are drilled into thermal dissipation pads on a PCB channel to heat away from the object. Use thermal interface materials (TIMs). So small gaps between a component and a heat sink to improve the heat transfer. Use thermal simulation tools. Other techniques of managing thermal management is utilizing thick copper traces, choosing the right board materials, optimizing the PCB layout. The another important is the handling, physical
Physical
damage.
damage. Yes, yes.
This is an important factor. Uh, Sometimes trolley falling down, case studies, exposure to water or insects, heat damage, electrostatic discharge damage, power overloads and surges. So you can see easily cracks, chips, bent components, corrosion, discolorations, moisture damage. All those are the challenges we should take. I think we are not
Surface.
talked about surface finish. If required, I can explain if the
Yes,
time
yes, yes.
permits.
Yeah, yeah, yeah. Definitely, you can.
This is nothing but a oxidation to prevent the oxidation. One second thing, this it's a media for the components mounting with the PCB copper pad. Many people, Japanese generally prefers to have OSP, that is organic solubility preservatives, wherein that it's a very low cost item for PCB manufacturer as well as the user, where application they need no media required, like hot air leveling, solder or leaded, ROHS, immersion T, nothing is required. They need only a bare copper, but it should prevent oxidation till the assembly. So this OSP will goes off during the assembly process in the first chamber itself. So that is OSP. And we have a electrolyzed nickel gold. This is again a costliest. One is the cheapest, another one is the costliest. Gold is, as such, but it will be used for mainly for the switches, buttons, and your remote controls.
Main like
Many of the automotive
contacts or
industry
something like that. Yeah,
contacts, yeah,
yeah.
because if many times, how many times you press, nothing will happen to the contacts. Otherwise, you'll have a pitting effect and it will form a carbonization and slowly
Yeah,
spark will generate, then slowly fire will happen. So wherever there those applications are there, it's generally NEG is preferred, electrolytic
correct.
nickel gold. Then hard gold is a special application again. Then HASL lead free, the ROHS and immersion tin. These two are actually similar, but HASL, hot air leveling in ROHS, what means you'll have a 1 micron to 40 micron variation in the surface. That many of the ICs will have a very fine pitch. There you cannot use this. This is a older technology. Nowadays, immersion tin, it's a pure tin, ROHS only, but it will have a 1 micron uniform thickness across the panel or the PCB. Industry nowadays, people prefer immersion tin more, wherein you cannot afford any. This application is most preferred one in immersion tin.
Okay.
I think that itself, I think enough for you on the surface
Yes,
finish.
yes, yes. That's a
Uh,
good,
yeah,
good
this is about incorrect
capture.
cutting. Yeah,
Incorrect cutting is basically the router or the
yes, routing.
PCB. Yeah,
Then it will have a misaligned components, physical damages, error
yeah.
discharge. All those things will happen. So you should have a proper program before cutting. They should do
Yeah.
first article inspection. All those things they should do. Okay.
Okay. Sure.
This, yeah.
Very good. Very good. Solder mask voids. Yeah.
Voids. These are pinholes and voids or gaps in the solder mask layer of a printed circuit board that creates copper traces being exposed to oxidation. Because immediately it will not make a problem, but in the long run, these oxidized copper will form a void. It's very dangerous. So this is also another challenge. We have to ensure all those things during the process.
Very,
Okay.
very, very nice. Very
Yeah.
nice. Yeah.
This continuous bias we have explained already.
Yeah, we spoke about it. Yeah.
Yeah, the mainly large wire diameters and pad diameters cause more discontinuity. Managing discontinuities, engineers and PCB engineers must carefully manage discontinuities to achieve high data series rates.
Very nice.
I think
I
this
think
is
pretty
all
much
about
main of
discontinuity.
the main challenges, main quality issues that probably one can
Yeah,
expect, one
yeah,
can or one faces, I would say, because there
yeah.
were some of these presentation that you made is
Mhm.
pretty much in line with some questions that I got from people who, yeah,
Yeah.
he stopped sharing. Yeah.
Shall I do stop sharing?
Yes. Yeah, you can if you're done. Yeah.
Yeah.
Okay. So basically, yeah, these are some of the issues most of the people who come across or the challenges being faced by the PCB people. And interestingly, a lot of these presentation are in align with the questions people have asked who wanted to know about the challenges and the things that how they can probably address those issues. So it's very well presented, Venkatesh sir, and really thank you very much for that. And we are now almost coming to the end of the show for today. So before we say sign off, you want to give any message to our young engineers, the process people, or the design people, or any of those people from the quality perspective of
Yeah.
their
My
boards.
main message is the young engineers or anybody working in PCB, communication is the 90% impact factor. Communication should happen every day, every minute with the floor people. Then it works very well. Without communication on papers, emails will not work here. Anything is required, emails, communication for documentation, record purpose required, but at the same time, at the earliest, it should pass through the main person who doing the production. That's a communication in the PCB. In the Japanese guru also told the same thing. Communication makes a big role here. That's the first point. Second point, whenever any garbage comes, you should have a TFC, means team feasible committee. You have to make study and feasibility study, awareness wherever there is some special characters and special process. Well, in advance before launch, should have a meeting with the all production HODs. That will also gives a more alertness in the shop floor. You can avoid any reworks or any failures during the process, and study each day as like a, see, your people say I am having 30 years experience in driving, but still any roads if you go daily there will be a failure mode effect. FMA will be there on daily. You don't know
Yes.
from where people will come, where we will have a accidents. So that alertness also should be there in the PCB. So these are the main factors. Keep your ears and eyes open. Definitely all can win the challenges. And lastly, safety should be first, quality must, customer should be best. This is what I will say.
Excellent message, Mr. Venkatesh. Thank you all, the audience, to join today's talk show on global electronics. As Mr. Venkatesh said, the communication is the key factor for the quality or for any of that issue. If I consider, if there is a effective communication, I think a lot of things can be solved. Almost I would say 75% things are solved if the communication is clear. Then 25%, the actual things that you are addressing and trying to resolve it. So I would say that definitely communication plays a very important role. And then he said being alert, right? So you have to be very, very alert in what you see, what you hear, so that you can act upon it right like this. That is where your company images is being shown, and how your company behaves. That's what it's important. With that, thank you very much, Mr.
Thank
Venkatesh, for
you.
joining today, and thank you for your time. I know that you are tied up with your delegates, with your business people, but you took some time and joined this. Thank you again. We will definitely be in touch with you for upcoming more shows,
Thank you.
because wealth is the I call it knowledge is wealth, because and sharing the knowledge is like you're gaining knowledge too, because when you share, you have already downloaded certain portion of your hard drive, and then you can, that way you can gain more knowledge by
Everyday
sharing.
learning. Everyday
Exactly.
learning.
Every day is a learning process. And thank you, Sandeep, for supporting the technical side of our show as always. And thank you, all audience. And we'll come back with another interesting topic next week about counterfeit components as well as the mitigation. So stay tuned with us with the Global Electronics, the Friday Talk Show. Your host Raju Kulkarni will be bringing you with interesting topics and knowledge sharing show. With that, be healthy, be smiling, and God bless. Thank you very much.
Thank you. Thank you, Rajesh, and thank you all.